Welcome back, amigos. So let's continue from wherever we dropped it last time. Yeah, right. Hope you learned a number of things from the last time, because right now we are going to dive a little bit deeper and we'll learn a number of other stuff that are very, very important and you need for exploratory data analysis, and also to be able to tell stories with your data. These are going to be very, very important. Right, let's get to it. So first thing is visualization. So what is visualization? Visualization is a way of you looking at your data by creating a plot out of it, right? You're not just looking at your data statistically. You know, a lot of persons get bored out when they look at their data, when they are looking at numbers, just numbers everywhere. A lot of persons get bored out. You don't want to go to that board meeting trying to convince your business partner or the MD or the CEO of the company why you guys should invest in this cryptocurrency or that cryptocurrency, or why you guys should put in a whole lot of money into the economy. You're trying to convince whoever you're trying to convince, your boss, your friend, or whatever, that you've gotten an insight with your data, and this is the next step you should take. You don't want to convince this person and then you'll be like, so the stock right now is so and so thousand, and next tomorrow. No. You want to go there and you show the person a plot, a beautiful plot, a progressive plot, whereby the person looks at this plot and the person is able to say, all right, I get the point, I see your view, and okay, probably I'll invest this amount. Right, you get it. So that's how we roll. So let's get into it. So first thing first is the type of visualization I'll be doing first is called histogram. Most of these visualization, I won't really go into them in details. I just want to give you an overview of how to plot them. And also, I am currently doing a kind of competition between two packages. One is called Mudblood Leap and the other one is called Seaborn. So Mudblood Leap is Mudblood Leap is actually the mother of Seaborn. Seaborn is another library that is built on the Mudblood Leap library, but Seaborn kind of output great plot. We'll see in a second. Right, so here is Mudblood Leap. I'm trying to plot an histogram using Mudblood Leap, and after plotting, this is what we get. Right, but then there's one last thing I would like you all to always note, that and that is I'll input a new cell under here, and that is the help function. Help is actually very, very important. So you don't limit the power of Matplotlib, because whatever you plot with Seaborn, you can plot it with Matplotlib. It's just that you might actually need more lines of code. That is just it. For example, let's look at this here. Our Matplotlib plotted this histogram, but our x-axis is not labeled, so I don't even know histogram of what am I looking at specifically. So for it to label your x-axis, you have to write another line of code, which is plt dot x label, and then you put whatever you want to call it price, right? And then we run. Now you see we now have price, no title again. You come back, plt dot title, you put a string and then you call the title, let's say histogram price. I'm just trying to be fast here, so we won't spend so much time. So when you run this now, you see histogram price is now the title. But then over time, you really want something that will help you to plot faster. But then many other times you might not be able to get around so many things using Seaborn. You most times have to come back to Matplotlib and write the long line of code. Right, you might be wondering what is PLT. Now, when we imported Matplotlib in the last video, which is here, we imported matplotlib.pyplot as PLT, not just Matplotlib. And if you haven't watched the last video, I advise you to go there and watch that video so you don't get lost along the way. So moving on from there, now when we do this, we get a title and a column for our x-axis. Now what you see on your y-axis is actually the count. Each Matplotlib, there's something we call bin. Right now our bin is 10. We can actually make our bin 20. You can make our bin 20. And when we run this, you see that the number of bars you have has increased. So the bin stands for the number of bars you have, and each bar runs from one range to the other range, and it tells the amount of, or the number of inputs you have in that column that falls within that range. So that is what an histogram is for. So an histogram can actually be used to see your distribution for both categoricals and numerical values. You want to know how, for example, our fuel type that we've converted, and we know we have two fuel types. We have both diesel and we have gas. You want to know how many cars run on diesel in our dataset and how many cars run on gas in our dataset. You can do that by just plotting an histogram of the file type. But yeah, I want to show you something using the help. Now, to see the full function of the histogram of the Mudblood Leap histogram, you can come to help and see and type plt.east. East stands for histogram. When you run this is what you get. You get a doc string. You know, remember what I said about doc string in the past video? So now this is the doc string for the histogram function in Mudblood Leap. Now this is the doc string, and as you can see, the histogram function actually takes in a whole lot of arguments. It takes in all these arguments. Can take in all these arguments. Yes, can take in all these arguments. Whoa, that's a whole lot. And how many arguments did we call here? We called only 3 out of these. So when you want to make your histogram more beautiful, you might really want to come down to this doc string and read more on how to make your histogram more beautiful, and even other examples were given at the end of the doc string, and different things you can just get from by just looking at the doc string of any function you like to work with. That being said, your doc string is very important. Don't forget it. We now move to Seaborn. Now Seaborn is as I said, another package that I'm going to be using to compete or to do a kind of competition with Barplot. So when I run this with Seaborn didn't just give me an histogram, it gives me kind of a density plot on it. Right, it's called KD, kernel density plot. The line you can see running through the histogram. It is just to show how high it went and how low it went, and all those other things at different points in time. But basically, you can see the histogram in the background. And the same thing, you can run the help for this too. You can run help for SNS dist plot, and it's called dist plot. Is dist plot? You remember in Matplotlib it's called histogram, but yeah, it's called dist plot because they see it as a distribution plot. And as I said, an histogram is used to see the distributions of datasets. So from there we move on to the bar plot. Now from here, basically, what can I get from the histogram? You can see how well spread your data is. From here now, I can tell you that most of the cars in our dataset are below $15,000, because I can see that the first bar, which is even below $10,000, is pretty high. The next one, which is a little bit above, is high, and these 2 bars alone can take up to, I believe they take close to 50 or 60% of the whole data set. And look at the rest, they are just small. So we know now that our data set contains more expensive cars than cheaper cars. Sorry, our data set contains more cheaper cars than expensive cars, because right, $10,000 compared to $50,000, right? So our data set contains mostly cheap cars. Then we'll move on from there, and then we'll go to the bar plot. Now, the bar plot specifically can be used to plot categorical variables. You can't use the bar plot to see the distribution of numerical columns. It's going to be a mess. You want to use your bar plot to check the distribution of categorical variables. And one of the categorical variables I've always been talking about is file type. Now, we call the file type function here in our bar plot. Now, it's bar plot, but in Seaborn is SNS. If you go back to the top again, you realized when we started this class, we imported our Seaborn and then we had aliases as SNS. So Seaborn is actually a very beautiful one, just as you saw here. We didn't tell Seaborn to label our y-axis, but it did. Our x-axis, but it did, unlike Matplotlib. So coming back to it, our bar plot is this way, and when you call in your categorical column into it and you input your data, you have to call your data and then tell it what data it should extract the column from, which is autos in this case. When you roll that into it, you get this plot, and this plot can tell you that we have over 75% of the cars in our data set to run on gas and the others run on diesel. This is a big bias in our data. If you should run an algorithm on this, your algorithm might be giving you a little error. So you need to work on this and try to reduce the bias and put a little. There are different ways you play around these things. We'll probably look at them in other classes or other courses. Now, the other one we have is Scatterplot. As I said earlier, I'm trying to compare both Matplotlib and Seaborn here. So in Matplotlib, there's a function called Scatterplot, and as you can see, your Scatterplot is actually beautiful. So I'll be explaining each of the arguments I put into this Scatterplot one after the other. So I called X and I called it autos. As you know, I'm trying to subset our data set, that the x-axis should be the price, the y-axis should be the length of the car, and then alpha equals to 0.5. Alpha is to tell these dots here to be transparent. So if I should put my alpha to be 1, you see that they are not transparent at all. And if I should put my alpha to be 0, you see that there is nothing on my plot, which means that alpha moves from 0 to 1. So I'm putting 0.5 because most of the dots plotted actually overlap on each other. And if I should leave my alpha to be 1, I will not see a number of informations are going to be missing, as you can see here, especially in this area. You can see this area, you can't really tell what is happening here. You can't really tell whether there's another dot here. So that's why I'm putting my alpha to be 0.5. You can actually make it 0.3. It won't be so bad as well. And then we come to the marker. Now my marker here, I'm using the dot marker, which stands for circular marker. But then you can actually play around with other marker variables. You can use D. And when you run this, you see it gives you the diamond kind of shape. But then I think the dot is just better in this case. So you can play around with a lot of things. And here C stands for color. C stands for color. You can actually change the color between red, which is depicted by R, blue, which is B, and green, which is G. So you can play around and find the one that you like the most. And yes, size of the marker. Now if you look closely at our marker, at our plot, you realize that the marker size varies. Why is this one small and why is this one big? So I'll be explaining that in a second. That is as a result of the argument I put in here in size. So I said the size of each marker should be equals to the city mile per gallon raised to power 2. The reason why I'm raising it to the power of 2 is because city mile per gallon is actually a very small value when you're talking about size of markers. So if I don't raise it to the power of 2, it won't be so obvious that the size of the markers are not the same. So basically, let's raise to the power of 2. So you have to play around it and know which one works for you best. So that's Scatterplot when we talk about a Mudblood Leap. And also, as I said, you can also use the help function to get more, to know about more things you can do. And here I put my X label, Y label, and the price. So now coming down here is the Scatterplot using Seaborn. It's plotting a Scatterplot using Seaborn. Right. So first thing is, when we looked at our Scatterplot, it is splitted into 2. That is because of what I put here, this column. I'll remove it. So we get one Scatterplot, right? So first thing is, I called LM plot. Now LM plot is a linear model plot. LM linear model plot. So the data, as I said, you put in what data you are getting, you are extracting your data set from, which is autos in this case. Y is the price. That's the y-axis should stand for the price. The x-axis should be the horsepower. Then I'm saying the fit regression is equals to true, which means I want this line to show. Although, if I don't call the fit regression equals to 2, the line will still show. But then, let me just make it false because I think we shouldn't be seeing the line for now. Then hue is equals to fill type. Now what I'm saying is, while it is plotting hue, is that the color. So you should color, hue stands for color. So you should color the fill type diesel in another color and the fill type gas in another color, since you know our fill type contains 2 categorical variables. Then scatter equals to true. Even if I don't put scatter is equals to true, as I said earlier, it will still display scatter plots. But then now let's run this and we'll see what we have. Whoa. I remember the line went away because I removed the fit regression. Fit regression stands for the regression line, is the regression line. And since you want a scatter plot, you don't want the regression line per se. But now I'm probably going to make it to become true. because I want to show something else. But you can actually see what I want to show you here, which is that the diesel cars generally don't have much more horsepower than gas cars. Or gas cars are the cars that have the higher horsepowers, and they are also the most expensive cars. So the most expensive cars in our data set are the gas cars, because you can see from the price here, from this side upward, that they are actually the most expensive. And also you can also see that the plots for the diesel cars is steep. But then let me use the regression line to do that, to show you that, and you will see. So you can start having some kind of insight about your data. As you can see here, the plot is steep, which means that a little increase in the horsepower, this line is steep, which means that a little increase in the horsepower actually brings about almost equal increase in the price of the car. Meanwhile, for the gas cars, increase in horsepower and in the price, generally speaking, basically I'm speaking generally, so increase in horsepower and the price of the car are positively correlated, but the correlation is not so strong. It's not like when the horsepower increased by 1, this increased by 10. So that is that. Then we move on to box plot. Now, what is box plot used to do? Box plot, you can use it to you can use it to visualize your categorical variable. Box plot is doing almost the same thing that a bar plot will do for you, but this time it is showing you some other things. It is showing you outliers. These are like outliers. Basically, before you call things outliers, you need to look at them closely. So these are like the cars that are not within the distribution. They are high up there when it comes to fuel type. When we talk about the price, because we grouped it by the fuel type, we have diesel and we have gas. So when it comes to the price, there are some gas cars that are just high up there. Their price is way above 30,000, which you can also see it up from our plot here. You can see that there is a space in between this side and this other side. There is a lot of cluster down here, and all of a sudden we see these other clusters up here, and there's a space in between. So you need to visualize different plots so that you can actually be able to buttress your point using different plots. Because if you just come here and are telling us this from here, we might not understand why these guys are up here. But with this scatterplot, you can tell why there is a space between these whisker. We call it whiskers, and then the rest. So basically, we can now tell why there are spaces there. So the box plot also shows you the distribution, gives you the median, the 75 percentile, the 25 percentile, and 95th and 5 percentile. That's where the whiskers are. So it's actually very important for you to visualize your data set using box plot as well. So here I just wrote a function. I'll run through it very fast because time is no more on my side. I'll run through it very fast. So I'm creating a function to draw box plots of different columns, putting Mudblood Leap as plot. So I'm saying for columns in plot columns, which is a list of columns, I'm creating a figure size. I haven't talked about this yet, but I'll talk about it very soon when we get to some other plots. So it's creating a figure and whatever. Then here I'm saying the box plot, the column should be equals to col, and by should be by, and ax equals to ax. So I removed something. Yeah, so the column is meant to be what is on your y-axis, and the by is usually what is on your x-axis. So column here is meant to be equals to col, which is for every column here. So the column should be col, the by should be equals to the by, which is going to be what we want to plot our box plots by. That is, should divide it by what? Because here we used the by equals to file type, so it divided our box plot into 2 because we have just 2 categorical variables in file type. So if we have used another by, it could have divided into a lot of number of other box plots, and then we output this. So when we run this function, you don't get anything out when you run the function, but when you now call the function, you get whatever you want. As you can see, the function is now plotting, is making a box plot of everything we put in this column, column, which I call cols. It's plotting everything and is using the file type to subset them. So we can see here that actually on that symboling, it seems more or less like the diesel cars have some outliers in that column too, and you can see two other outliers, which means probably there are really some outliers there. So you can actually just look through and you see things, two outliers again, another column, and then a whole number of outliers, still having those two outliers up there. So basically, that is what the function does. Instead of rewriting codes over and over and over again for that, just do that. So now, what I want to do here is I want to do something that we call correlation matches, because as you see, I've mentioned correlation once. So correlation is showing the relationship between two different columns, two numerical columns, how strongly correlated they are, whether they, when one increases, the other increases equally, or when one is increasing, the other decreases, or when one increases, nothing happens to the other one. So we want to see the relationship between these different numerical columns. And how do we do this? We get the correlation of a column of a data set by calling this on numerical column on the data set by calling authors dot correlation. So this brings out a matrix, an equally sized matrix, an n by n matrix of, and the x-axis of the matrix, that is the rows of this matrix, contains the names of all the numerical columns, and the columns also contain the name of all the numerical columns. So when I plot this, I'm putting a note equals to true so that it will show us the different values of each correlation. That is the correlation percentage. So if it is 1, if the correlation is 1, it means they are strongly correlated, and if the correlation is -1, it means they are strongly negatively correlated. If it is 1, strongly positively correlated, which means as one is increasing, the other one is increasing. But if it is -1, it is strongly negatively correlated, which means as one is decreasing, the other one is increasing. So now let's get to it. But then looking at our plot is messed up. So I would like to introduce you to Mudblood Leap notebook. Now, what we've been using before is Mudblood Leap inline. Mudblood Leap inline is just to ensure that your plot shows inside your notebook. But now Mudblood Leap notebook gives you a whole new aesthetic to your plot. Why is this not showing? Please show. This is not kind of showing. I don't know why. So I think we'll probably just have to move on and leave Barplot Leap notebook out of it for now and use the other method that I have in mind, which is creating an axis and a figure. Alright, so now first thing first is, why should I create a figure and an axis? Now you want to create this so that you can actually scale your plot. For example, the last plot we made using the heat map, the plots were jam-packed. What we want to see, we're not seeing well, and other stuff like that. So you really want to create a figure and an axis so you can actually increase the size of your figure. Now I've put it to 15 by 15. I can make it 5 by 5. Let me make it 5 by 5 so we'll see. Let me run this. It's meant to return a very, I'm putting my plot leaping line back in place. So it's meant to return, as you can see, this is small and the text in there are still jam packed. So I'm going to make 15 15 and we'll see what happens. Yeah, so the plot is bigger, and we can see the correlation of each row against each other. For example, here this -14 is the correlation of wheelbase against normalized losses. So you can see the correlation, and -15 is its map, highway mile per gallon, normalized losses -56. So most of these guys are negatively correlated against each other, as you can see here. Oh, this is positively correlated, highway, horsepower, and the price. Wow. So horsepower, the horsepower of your car actually affects the price of your car a lot. And also we can see here that the horsepower also affects the size of your engine. So the horsepower of your car determines the size of your engine and other stuff like that. And then we come here, highway mile per gallon and city mile per gallon are highly correlated. That is expected. And highway mile per gallon and price is negatively correlated. So if highway mile per gallon is going up, your price is coming down. Alright. So, and highway mile per gallon shows the amount of fuel consumption, how much fuel your car consumes. Alright. So it means for every mile, how many gallons do you spend. So if you're spending more on fuel, the price of your car is meant to be lower. That is what this is saying. And if the price of your car is high, you're meant to be spending not so much on fuel. Right? We'll see to that in other classes. But then this is what heatmap shows you. It gives you a whole lot of insight about your data set. You can tell a whole lot of story with just your heatmap. As you can see, I've been telling since I opened this up. So you can tell a lot of story with your heatmap plot, and it's actually very, very important you do your heatmap before you move into doing other plots. We are almost done. Now there's this other plot called Barplot. Now why Barplot? Barplot actually plots numerical columns against each other, plotting them using the Scatterplot. So it plots numerical columns against each other, and it's another beautiful thing to see. So when I run this, it is going to create something like this, a matrix as well, but then it's going to be plotting numerical columns against each other. It's coming. Now, Barplot actually requires a lot of computational space because it is trying to make a whole lot of plot at once and put everything in one space. This is an image. You can export this as an image. So basically, looking at this, oh god, if I had run this on if I run this on all the columns in the dataset, it would have taken longer time for it to run. But I ran this code on this dataset. I have subsetted here where I call codes, yes, on just 1, 2, 3, 4, 5, 6, and it took that much time. So basically, you really don't want to run your Barplot on all your datasets. You want to probably do the heatmap first, and then you select some columns you want to see, you want to look at closely, and then use the Barplot to see whatever it contains. So that is that for Barplot. And as I said, you can always use your the help function. You can always go help SNS Barplot, and you see other functions that your Barplot can actually take in to make your Barplot look more beautiful and presentable. Then you're presenting them. We have the swamp plot. These are just like extras. You can always look at them and be able to read the codes as I wrote them, the way I wrote them. They are well understandable. So when you run your swarm plot, as you can see, it's just like bees, swarm of bees. That's why it's called swarm plot. So basically, that's that. Then violin plot also. You can see violin plot here, and that's that again. That's another one. Now here I am combining two plots together, swarm plot and violin plot. Nothing spectacular. Just putting the second one after each other before running my code. And here I put while limit to be equals to 0 because when I looked at this 0, it means that this plot went a little bit below 0. So I just put it at 0. So let's just cut out that 0 and let's see that. So now we've come to the end of most of the things we want to do today, but I want to tell you one last thing. I want to show you one last thing, which is how you can export your plot. Because you've made a beautiful plot, a wonderful plot, and you're wondering, how am I going to export this plot? Am I just going to drag this out, or how am I going to do it? So when you want to export your plots, let's say we want to export this last plot we just made, we're going to call plt.savefigure, then savefig, then we open and close bracket, and we name it. We name the figure. So let me call this and to round up as soon as possible. So let me call this upendo1.jpg. I run this. So it's returning an error for me. So it's telling me that it supports PNG, blah blah blah. So you just choose the one it supports, one of the ones it supports, and let's say we'll go with PNG, and you run. And now you're asking me where is the saved plot. You come back to that folder you created, and you find your plot there. When you click on this, you see the image. It is saved. So you can always take this image and put it into your presentation file format and whatnot. I hope you like this video. I tried my best, but I'm currently working from a very hard side here. I need to rush things before my laptop dies. Hopefully we'll meet some other time. I'll create more videos on cleaning your data sets and machine learning itself. Thank you for watching, and I hope you learn 1 or 2 tricks from this, and let's see how you do in your next exploratory data analysis. Bye.